I need to talk about some synthetic division. Synthetic division is not near as invasive as long division. It's simply a shortcut method. Instead of using long division, we omit the variables and use just the coefficients. The divisor, there is a condition. It has to be in the form of x minus k. So down here, the 2x minus 5, that's not in this form, x minus k. X, this right here has 1x to the first power. Literally, that is how it has to be. Here, the problem is this 2. So that would not work. We couldn't use synthetic division with a divisor like that. Over here, for x squared plus 3, we couldn't use that because the form is x to the first power, not x squared or x cubed or x to the fourth or anything. However, here we can use it because it's 1x to the first power, and actually it looks just like the form, doesn't it? Even down to the minus sign. So the constant is going to always be the k value. The coefficient of x is always 1. And so is the power of x, always 1. In this particular divisor, the k value would be 5 because it goes exactly by that little divisor formula. So the k value is 5. However, here we have a plus. Well, we know from algebra that a plus is the same thing as minus a negative. So if our k value here would happen to be negative 3, and x minus a negative 3 ends up being plus 3, our k value would be negative 3. You could also think of it as the opposite of what you see. If you had a divisor x plus 7, then your k value would be negative 7. If you had a divisor x minus 7, then your k value would simply be 7. You also omit the variables. I think we talked about that. Variables, I can't spell. And it's also based on simple addition and subtraction. Okay, so your setup is even different. Here, you have your f of x divided by x plus 2. And we've already stated that your divisor must be in x minus k form. Well, it may not have a minus sign like it should, but it is the same thing as x minus a negative 2. So it's in 1x to the first power, though, isn't it? Remember, your power is always 1 in synthetic division, in your divisor anyway. All right, so we express x plus 2 in the form x minus k, which I just did, by writing it as x minus a negative 2. So our k value is negative 2. Negative 2 is our k, and our coefficients are 5, negative 6, negative 28, and negative 2. I'm going to write it like I did in class just to show that it's completely different. We use addition vertically, and we use multiplication times the divisor. That's similar to long division, the multiplication is. To get started, bring your 5 down, your very first coefficient. And 5 times negative 2 is negative 10. Add vertically and multiply around. Add those together. Negative 16 times negative 2 is positive 32. Add, multiply around, and add again. To write our quotients, just like long division, when we plug our variables back in, it's 1 degree less than the original problem. So my answer, or my quotient, 5x squared minus 16x plus 4, my remainder, negative 10 over x plus 2. So we write it just the same as long division. This is just a shortcut, dealing with numbers only. The missing terms concept still applies in synthetic division as well as long division. So let's use synthetic division. We're going to do a couple. We have x minus k form. So our k here would be 3. And do we have any missing terms? We've got x to the 4th, x cubed, x squared, x to the 1st, but our c value is missing, isn't it? Our constant. So what would we put as a placeholder? We would put 0 because we still need it. Let's see, 3 into 4, negative 3, negative 20, negative 1, and 0 as a placeholder. Let's get started. 4 times 3 is 12, add. 9 times 3 is 27, add. 7 times 3 is 21, add. And 20 times 3 is 60, add. And that's my remainder. My quotient is 4x cubed plus 9x squared plus 7x plus 20 with a remainder of 60. And again, that goes over your original divisor. So missing terms does apply. Solution. Your solution will be 1 degree less than the dividend. Okay, so hopefully, I'm hoping maybe you could do this next one and then you could turn on the video and see if you're correct. I'm trying to manually focus here a little bit. There. So you have the big f of x, and we're going to be dividing by negative 4 for my k value. So negative 4 and 1, 4, 2, 9, and our constant is 4. Bring down. 1 times negative 4 is negative 4. Add. 0 times negative 4 is 0. Add. 2 times negative 4 is negative 8. Add. And 1 times negative 4 is 0. So in this particular case, we have no remainder. Or 0 is the remainder, right? So to write our quotient, x cubed, x squared is 0, so we don't have to write that, plus 2x plus 1. And that is our quotient. I have one more video. It's short and sweet. It's the remainder theorem. So what does each of these remainders mean? So check the next video. And also don't forget your quiz.